talking about pollution that is man-made. Everybody knows about the Volkswagen scandal, so I'm going to skip a little bit this. And our services starts very high above, like Ranjit told. We start with satellite imagery from the European Space Agency partnership with the Copernicus and Atmospheric Monitoring Service. So we pick up information, and to give insights and to increase the resolution of the data to city level and to street level, we have created air quality sensors that we install in moving vehicles, so we can get air quality and air pollution measurements in real time. And also we recently started to use it in smart luminaires in a partnership with the former Philips Lighting, now it's called Signify. So we can use their own electric poles, so we can install our air quality sensors there. Of course, our solution is scalable. We can use open data and other sources of the information that the city has. So I think that it covers all the gap that from satellite to street level. Here you can see some images that we provide for remote sensing. So you can see Portugal with the higher particles 2.5, and in this case was created by the major fires in 2016. But what we want to do is to create street level and to provide routing people in cities so they can avoid hotspots of pollution. So what we have used is to feed all this information in machine learning algorithms that we developed. And so we are creating air quality forecasts. So where and when hotspots of pollution may appear in streets. So we help people to route in city to avoid hotspots, or if they have some kind of medical problem, we have tailored individual medical and health profile that helps people to receive alerts, not alerts or notifications. So it's not only the question about receiving a general alert, but to provide insight information for individuals. And this was one of the prizes that we have received in 2017, the Copernicus Masters from the European Commission for the use of satellite images to help people. So what we are doing, basically until now, we are focusing the business to government. Business to government with revenue and break even. So we break even in 2017. We developed 2 platforms for municipalities. We are now in 2 living labs in Portugal, and we are cross-selling our sensors in the Iberian market and Turkey with Signify. And of course, we are looking now for additional platforms and to use our data in additional platforms. The business to business that we are envisage, it's mostly for the environmental analytics and routing. So as I said, we want to create analytics and allow people to use our service as a ways for traffic. And we are tackling the health private sector. We know that the health insurance and the health private sector, it's one of the major payers in the sector. And if we just can reduce one hospitalization, we spare between 4,000 to 50,000 euros to the insurance companies. And of course, our goal in this program is to scale up in the newly smart cities initiative in India. We have also Hong Kong, USA, and Uruguay also envisaged to participate. Uruguay, it's more advanced. They are requesting already our sensors. USA is because of the MIT Portugal that we participated. So here you can see one solution that we have installed in our platform. So you can see the cup in the bottom. That has the solution with the Philips Lighting that is measure our air quality data in Matosinhos. So just a brief summary. We started this company in 2015 in July. So our goal there was business to client. So our goal was to improve fitness and health. And in 2015 and 2017, we have been incubated in the European Space Agency Business Incubator Center, Portugal. And we think that every problem has a space solution. We participated in the Building Global Innovators of MIT Portugal, and we have received the first prize on medical devices. We participate also in the Copernicus Accelerator between 2016 and 2017. And now we are again part of the Climate Key Careers Accelerator from the European Institute of Technology. We are already participating in 2017, and we are starting in April 1, the second stage of the accelerator. So as I told, we have received some awards. In 2015, we have been the winners of the 6th edition of the Building Global Innovators MIT Portugal for the health IT and medical devices. In 2016, in November, we received the Innor Stars Award from the European Institute of Technology dedicated to health. In 2017, we received the Copernicus Master from the European Commission, and now we are part of one entity that is called Copernicus Academy, that is dealing with the use of satellite imagery for and teaching the use of satellite imagery for others. Our company, so it's me. I'm a mathematical developer. I'm still a researcher at the university, and I managed to have the company as a spin-off from the university. We have Paul, that is a business developer and GIS analyst. We have Carla, that is a chemical developer. We have Anatut Bond, which is a professor from the university and head of the allergology service in the university hospital. So she is helping us in connecting the medical profile with the pollutants. And of course, we have our mentors from MIT, from IPN, from the Copernicus Accelerator that help us in developing our goals. So I think that I finished. Thank you for your attention, and I'll be willing to answer some questions later on.
Thanks, Pedro. It is generally a need of the hour. We need to talk about air pollution and the monitoring devices. And regarding the question, we will take every question at the end of the session. So
sure. Okay.
Yeah. So going forward, I am just introducing our next panelist. The company is Enging, is again a Portuguese company. The company is working on the industrial IoT system. They are working on the industrial maintenance, predictive maintenance. So to learn more about from such technology, this is a very innovative technology. I'm just introducing Mr. Walter and team. So yeah.
Hello, good morning.
And so over to you. Yeah, Mr. Walter. Mr. Walter. Hello. Mr. Walter, can you hear us? Hello.
Yeah. Hello.
Yes, we can hear you now. Please go ahead.
Okay, sorry for the confusion. Are you seeing the screen right now?
Yes.
Yes.
Okay, sorry. Okay, let us begin then. As I was saying, or trying to say, sorry for the informatic problems. Enging is a Portuguese company that dedicated itself to the creation and development of software solutions for predictive maintenance. In this case, orientated to the condition monitoring of electric machines. So what we were able to do was to develop a software that is able to detect faults in these assets. So what are the main problems nowadays that you can encounter in the traditional approaches? Most of the approaches you can have access right now are extremely costly and inefficient. Basically, they will induce you to a high number of failures, what we call false positives and false negatives. In this case, false positives is when a software or a traditional approach gives you a fault detection when in reality nothing is happening and everything is okay with your real assets, and the opposite in case of the false negatives, when no currency is given by the traditional approach, and in the end you have a fault in your assets. So this will lead you obviously to unplanned stoppages, induce you obviously to a high downtime costs, and basically what you will gain in the end is high maintenance costs, obliging you to have a high risk of exposure. Basically what you will have in the end, it's a low efficiency in the maintenance actions. So we are completely different. At this moment, we've developed and created, as I told you, a completely different approach. It's an approach that is based in electrical and mathematical models, in this case, a mathematical algorithm that in the end will give you actionable data. So our core business is precisely the software and algorithms. We are based in deterministic models that will be able to give you a fault diagnosis and a power quality energy analysis and diagnostic. So we start from the hardware and sensors, which are completely non-invasive. This is extremely important to enhance. We don't need to place any sensors inside the real assets, as in reality, we'll be only taking the measurements of electrical variables. So by taking these measurements of the electrical variables, currents and tensions, we will pass it through a software, through the mentioned mathematical algorithm, and then reach a very user-friendly interface that we call ePredict, that basically it's an online and in real-time monitor condition of the real assets. So what are the solutions that we've developed? As I told you, we are very focused at this moment in transformers. So we have three solutions for transformers, power transformers that we call TCM, that have the on-load tap changer, the low power transformers, which don't have the on-load tap changer because they are manual or fixed, and the OPTCM, which is basically a solution that we developed for nuclear power plants, for the emergency transformers, auxiliary emergency power transformers of the nuclear power plants. The other solution we've developed to industries is the MCM, which is basically the software for fault detection in electric motors. So what is the TCM solution for power transformers? Well, basically, as I told you, it's a completely non-invasive approach and technique that uses intelligence and smart algorithms. Basically, we start from the characteristic plates of the transformers, then the algorithm through the acquisition platform will acquire currents and voltages, and then makes the first reading. After the first reading, he will make the comparison with the characteristic plates. Then he will have an actual monitor of the transformer. The second reading will read the first reading and will also go to make the comparisons to the original characteristic plate. So, and this goes on and on and on every 3 seconds. That's why we are calling it as smart algorithm or intelligent algorithm, because it will be able to give you the actual status of the transformer in real time, and basically it is completely adaptable to all kinds and types of transformers. Why? Because we're taking the same values, the electric variables. This will be placed in a semaphore alarm system, green, yellow, and red, in order to give you or not the alerts in a simple interface with the goal of increasing the reliability of the transformer. So basically, this is the example. It is of simple installation. We take the voltage and the currents of the transformer, as you can see, in a completely non-invasive way, independently of the kind of transformer we are talking about. So what we are able to detect? Well, basically, we are able to detect the main faults of a transformer. In this case, we're able to detect the faults in core, in the windings, and in the on-load tap changers. Basically, as you can see from the photo, the on-load tap changer is completely carbonized at this moment. It should be copper with a copper color and is completely carbonized. So basically, we are able to detect not only the electrical faults that happens in the core and windings, but we are reaching also a more mechanical fault detection in the on-load tap changer. Going on, this is the ePredict MENTC platform. And here you have a small example of what you can see in the software. So you have all the information concerning the transformer, okay? We have the excitation currents, we have the on-load tap changer, and basically we want to reach this layout. Basically, you have this information about the windings, about the core, and about the on-load tap changer. The 3 semaphore lights you have in the top of the screen. In this case, this is a problem in the windings in the first phase. So, apart from giving you a fault detection, we will pinpoint you where the fault is, and in the segment where the fault is, I will be able also to pinpoint you where the phase, which is the phase where the fault was detected. As I told you before, it is a fault in the windings and a fault in the first phase of the windings. Okay. So going to the low power transformer, which basically it's the same software developed, but in this case applied to an active, a real asset with lower cost of acquisition. So we had to adapt also the software and its price. In this case, for the low power transformers, you will not have the on-load tap changers. This is the reason why we only need to take and acquire the currents of the medium and the low voltage side of the transformer. This is the graphic. Basically, we are acquiring in the data acquisition platform the current signals of the transformer. We are sending it to a gateway. And from this gateway, we will send it to a server. One thing, the server can be either in Enging or can be in client's server, as long as we have the space to run the algorithm. The idea, obviously, is to be able to pass the algorithm with a remote monitoring and then put it in a layout in a user-friendly interface, basically to reach a fault diagnosis and a power quality analysis. So in this case, and a little bit different from the TCM, from the power transformer solution, the low power transformer, EMS LPTCM, will be able to detect and give you a real indication of the internal state of the transformer. It's like on-off system that in the end will give you the fault detection on windings and core, but will not at this moment pinpoint you where the fault is. It will give you have a fault or you don't have a fault information. So The platform is very easily interpreted. That's why it doesn't need specialized technicians. You have the load factor, you have the severity factor. Here is in green, for instance, but it can, as I told you, be transformed in yellow or red depending of the level of the severity of the fault that we are able also to analyze. You have the excitation currents, you have the primary and secondary analysis of the electrical variables. So you have all the information concerning the low power transformer. We've also developed the same system, fault detection for motors. In this case, it's very easy. We've taken the example of a submerged pump. You have the example for you to have the idea that independently of the location, the size, or the very extremely difficult access to the real asset, in this case it's a submerged pump, we don't care. Basically, we just need to have access to the control panel. From the control panel, you see right here, we take the currents and voltages signals, we pass it to a data acquisition platform, send it to the gateway, then to the server, then it goes to remote monitoring in order to reach the layout of a fault diagnosis and energy efficiency. Basically, it's the same system as the low power transformer system. It's very easy to install and very easy to analyze. Well, at this moment in the motors, we are able, as I told you, for the transformers, also to detect you the fault and also to pinpoint you where the fault is. In this case, we are able to pinpoint you if the fault is in the supply, if the fault detected is in the stator, if the fault is in the rotor, and we are starting here to enter the pure mechanical faults. Eccentricity, for instance, we are able even to reach the bearings, okay? Apart from the eccentric rotor misalignment, we are able also to reach the bearings. Obviously, that we are able also to pinpoint you if it is a load problem. For instance, in belts or pulley systems, we've applied these systems, for instance, to paper industries. So this is the main faults we are able to detect, rotor, bearings, and stator. And this is the layout of the software. You have the 5 diagnostic, main diagnostic alerts: power, stator, rotor, eccentricity, and load. This will change color if we reach a fault or not detection. You have the load factor, you have the voltage and currents measurements, you have the load capacity, the velocity, and the torque of the motor. Basically, we are able to monitor the whole part of a motor. Well, the advantages, in our opinion, are very easy to understand. It's accessible because it's a remote and online system. It will be reachable, for instance, in a smartphone. Therefore, the access to data can be done anytime and anywhere. It's accurate. Why it's accurate? Well, because we are using electrical variables, which basically are the most sensible source of information you can get in the world, and the most reliable, because it will permit us to give you an early fault detection and to pinpoint where the fault is in the real assets. Simple. Why? Because it's completely non-invasive. It's your propriety. It's your real asset. I don't need to have to open it to place any sensor. I just need to have access to currents and voltages in the electric panel, as I told you. It's of simple installation, user-friendly interface, prepared to non-specialized technicians, and doesn't need any complex installation procedures. The main benefits, well, once again, real-time monitoring, non-invasive, applicable to all and any type of electrical machines, smart algorithms that we learn with the evolution of the fault and give you that detection and alert in order to reach the increased availability, delaying most probably the major investments, that's the idea, and reducing the costs. Here you have, and basically we all want to reach a reduction in the maintenance costs, a reduction in the unplanned stoppages, and the reductions of these unplanned stoppages, basically a reduction in the stoppage time. Basically, what we all want is to increase efficiency. That's what we are working on, and that's what we are able to offer you. So the business model is divided in two: a permanent online system where you have access and you can buy the hardware and the software, and you will be responsible for the monitoring, and we will stay well, ready to give you all the support you need and to send you the detailed reports upon a payment, or you can opt for a maintenance as a service. In this case, we will make monitoring, okay, and we will give you in each fault detected an extremely detailed report of that fault. So basically, in the maintenance as a service, you have access to expertise. You have access to all the evolutions in terms of the development of the software. So these are the two business models you can have access. This is a team, as you can see, well, most of them are electrical and mechanical engineers, and basically this is structured in order to have, well, basically 85 to 90% of the people related to development, basically, and to operation processes. And this is a traction we already have, okay? We have EDP, which is the electrical Portuguese company. We have UK Power Networks in United Kingdom, Terna in Italy, Votorantim, it's a cement factory. We have Galp, a petrochemical, Iberdrola, you all know it. Iberwind, it's a wind farm company. Rede Elétrica de España, and we have also Almaraz, Trilho, and Cofrentes, as I told you, nuclear power plants. In the bottom, you can see EPAL and Águas de Lisboa and Val do Tejo, which basically are water industries. Finza, that's basically a wood company. Manvia, a maintenance company. Basically, what I want to say to you is that these monitoring solutions are applicable to all kinds of sectors and industries. That goes from electrical power plants to nuclear power plants, passing through very normal industries in the market, like Vista Alegre, what you have, it's a ceramic company, or Caima Celtejo, which is a paper company. So it is applicable to all electric machines as far as they are critical to the production process. Therefore, at this moment, we are running very hard for the renewable energy at this moment, especially in the offshore, as we are able to monitor online and remotely, for instance, generators, power converters, and the transformers in each eolic based on offshore or onshore. So I hope to be able to give you the information you needed, at least for you to have the first insight. And obviously, I'm completely available for any questions that may arise. Thank you very much.
Thank you, Gol.